So just wanted to talk a bit about like kind of the overall design ideas that went into this robot, which I have since dubbed the LCR 21 for Ladder Climbing Robot 21. This was my original plan. I wanted to try to challenge myself to use one actuator. I wanted to see if I can get it done with one, just because I thought that'd be neat. It didn't quite end up going that way, but we'll get to that in a minute here. So for the original idea, it's going to use one actuator with the climbing claw on top. Now, this claw, as well as this claw down here, I'll talk about in a second, but these claws had those rubber bushings on them, which allowed it to have some kind of flex, or some degree of flex, so that it could get over the rung. And then I had a backing up against it so that the claw could bend down, but it wouldn't bend up too far because it would have this brace up against the back of it. Okay, so that was the idea. So it allowed it to bend down, but it wouldn't allow it to kind of bend too far that way. And I just have that on one actuator, and that will go up and down. The idea for the latching portion of it is the static claw would not be on an actuator. So this would be mounted somewhere around the middle-ish of the robot, and it was gonna function the same as this claw. It was actually going to be an identical claw. The only difference is it wouldn't be on an actuator, so it would just be kind of attached to the robot. And as my robot climbed up, the idea was this claw would kind of clink, latch onto the rungs as it went up and hold it in position so that the climbing claw could then reach for the next. That was the idea. What I found was it was hard to kind of get that sweet spot in spacing for the position of the static claw so that it would actually grab onto the rungs as the robot climbed up. What I ended up doing, instead of trying to like find that sweet spot that worked for the spacing in the rungs, because the rungs were all a little bit differently spaced from each other, I ended up doing is this. So I kind of revised my plan. I added a second actuator. So we still have our climbing claw. That actually remains basically the same. I've just moved my static claw onto an actuator, and I actually used a short actuator because I didn't want this claw to be reaching for another rung. I actually wanted this one to kind of function the same as this, but by putting on an actuator, I've allowed for that variance in height between the rungs, right? So as the climbing claw would pull up, the short actuator would allow that latching claw to search for that rung that the climbing claw has already grabbed onto, grab it, and then latch the robot there. So then that frees the climbing claw up to reach for the next rung. The other design kind of hurdle was stabilizing the claws, because they could actually spin freely on the actuators, because the piston and the actuator could just spin. And I did find that I tried it without them because I just wanted to see if I needed to do this at all, but I did, because I did try it without any kind of stabilization, and not every time, but some of the times the claws would spin out of the way, and then they wouldn't be facing the right direction. They needed to latch onto things. So what I ended up doing is I made some stabilizing arms, basically just kind of attached to a point on the claw and then a point on the chassis of the robot, and they have a joint, and they just move like so, and the only thing they're doing really is preventing rotation of the claw head.
It seems like if you try to put logic in a circuit after a coil, policeman doesn't like it.
Yeah.
Okay? You gotta put any logic in that. Nice, Connor. Looks like a weird little snake. Doesn't it? It looks like little snake heads.
Yeah, kind of.
Little fangs.
Oh, come on.
Good job. You just need to make
One of the smaller challenges I faced in this was when I implemented these stabilizing arms. I noticed if it went too far, there was a chance that this could push inward and it would buckle. So it would come up straight, and then when it started to come back down, instead of this kicking out this way, it would kick in, and the whole thing would buckle and prevent this from coming down, right? So easy fix is I just put on these little guys here, and they're actually different lengths because for the different length cylinders, I found that this was what worked best. But they basically, when this comes all the way up, this pushes against this part of the arm here, which will prevent the whole thing from buckling inward like it was doing before. So it's just kind of like a little small feature, but I just wanted to highlight it because I thought it was interesting. Yeah. So a major snag I'm running into is the reed sensors for these. Because of the way I had designed the bracket for holding the actuators, these brackets don't fit in there very well. Now, one of my reed sensors, it's a little hard to see, this one here, I was able to actually take that out of the bracket, and he's on there pretty good. This one though, I can't figure out a way to take this out non-destructively. So what I had been doing is I'd just been taping it around the whole thing in position, and because of that, because tape is tape, you know, it can stretch a little, and it would move, and because it would move, I would lose signal on my reed sensor because it would shift out of position where it needed to be. And it's just kind of like been a roadblock that's been hard to overcome. Just again, because of the design I have for this, the way I did it. If I did it differently, I wasn't thinking ahead when I mounted these like this. But if I did it differently, I would allow some space somehow in here for these to fit on there. Because that's really what's killing me, is I don't have room to fit this on there. And without a reed sensor to control my logic, obviously one could understand how that is a problem. As far as the logic goes, a lot of this I'm not using right now because it's kind of just been a testing environment so far. I admittedly have not gotten very far on the fluid sim portion of it, but I'll just show you what I got. So up here, it's going to latch on power for our whole system, both up here and down there. So we'll hit go. Okay, now the reed sensor, boom. Okay, so when that goes high, timer counts down. So this is that first one there. Break that first slot 1 on there. That's the output signal to send my actuator up. Okay, you can see we got the timer. When that timer expires, my up actuator expires. My left, the smaller actuator, that one will shoot up, and then this will be my return for the other actuator. That's about as far as I've gotten. I don't even know if that would work. Again, I don't have it I don't have it all hooked up. But it's just kind of like, theory in and out right now. But that's with the timer, as you can see. So it's just kind of interesting. Just as we boom, timer counts down, and when that expires, we shift over there.